Hello, today we're going to do tree diagrams. This is patterns and or probability and data management, unit 16. It's lesson 8-20, which is found in your jump math workbook on page 201. This is rather a short lesson, so let's make quick work of it here. We're going to go over all the key information, and that's going to set up further combinations of choices for probability. So we've kind of figured out how we can calculate probability of a single event, which is we look at the total number of outcomes, and then we look at the number of outcomes that are desirable. And then we develop a fraction or a percentage based upon the total outcomes and the number that are desirable. So the number that are desirable are as the numerator, and the total outcomes are as the denominator. So let's take a look at it anyway. So in the gray box here, it says, at sports camp, Aaron has these choices. In the morning, gymnastics or rowing. In the afternoon, volleyball, soccer, or rugby. Aaron draws a tree diagram so that she can see all the combinations of choices. So Aaron has drawn this tree diagram here. I'll indicate it in the gray box. And you can see it's a tree because it's got the branches. It's actually like an upside down tree or a root system. So in the morning, she can either do gymnastics or rowing. And in the afternoon, she's got the option of the three. Notice the option of the three are repeated morning and afternoon. For each option. So in the afternoon, if she does gymnastics, she can still do volleyball. Or if she does rowing, she can still do volleyball. Step one to do a tree or to create a tree is she writes the names of her two morning choices at the ends of two branches. So here's branch one, here's branch two. Step two, under her morning choices, she adds three branches, one for each of her afternoon choices. So you've got 1, 2, and 3. And she follows along the path of the branches from the top to the bottom to find Aaron's choices. So the example, the path highlighted by arrows shows gymnastics in the morning and soccer in the afternoon. So you can see that this one's a little bit bolder, and so is this one. So she did gymnastics and soccer. It's one option, but you can see here that there are a total number of 6 different options she could have chosen. So 6 combinations of those two activities. Let's take a look at number 1. It says complete the tree diagram to show all of the possible outcomes of flipping a coin. H is heads, T is tails, then drawing a marble from a box that holds 3 marbles of different colors, red, green, and yellow. So we are doing heads and tails. Now, obviously, in our first event, which is flipping the coin, we have 2 options. It could be a heads or it could be a tails. Now, the tails is already put in for us. And in the marbles, you can see that we have 3 options of red, green, or yellow. So if we flip a heads, we could still pick a red, we could pick a green, or we could pick a yellow. If we pick a tail or we flip a tails, we could get a red, a green, or a yellow. How many combinations of outcomes are there? Well, this question is actually asking, how many different branches are there in the tree? How many different ways could this be solved? And the answer is 6. And I'm getting that by counting each one of these as a separate branch. Okay? So if we take a look at the last section of the tree, and we count up the number of different options, that's the different number of outcomes. That's the possibility. Let's take a look at number 2. Matthew's camp offers the following activities. Morning, drama or visual arts. Afternoon, dance or creative writing. It says draw a tree diagram like the one in question 1 to show all of the combination choices. So of course we are going to do that. We're going to draw our tree diagram. Now in this case, they haven't drawn the tree for us. They're asking us to kind of fill that in, and we can do that pretty simply. I changed my pen color to blue just so it's separate from number 1. So in my tree, I've got 2 options in this. In the morning is drama or visual arts. In the afternoon, I've got two options, dance or writing. Creative writing. I'll just call it writing. That's pretty sloppy, but there you can see it. That's a tree diagram. I've got event 1 up here and event 2 here. So morning and afternoon. These are all the outcomes. You can see that there are a total of 1, 2, 3, 4, 4 different combinations of choices that Matthew could do at camp. Okay, let's take a look at number 3. Number 3 says, draw a tree diagram to show all the combination of numbers you could spin on 2 spinners. Okay, so they want us to draw a tree diagram for these 2 spinners here. And you can see this spinner here. Let me just move this up. The first spinner here has got 3 different outcomes. You could have a 2, a 3, or a 4. And the second spinner is simply a 1 or a 2. Okay, so let's draw our tree diagram. Again, I'll change the color maybe to green so that I can separate these out here. So the first one, I've got 3 different outcomes. It could be a 2, a 3, or a 4. In the second spinner, it could be a 1 or a 2, a 1 or a 2, 1 or a 2. So you can see that there's a total of 6 different outcomes that are available. It could be a 2 and a 1, a 2 and a 2, 3 and a 1, 3 and a 2, 4 and a 1, 4 and a 2. Now, A says, how many pairs of numbers add to 4? So if I want to know how many add to 4, I'd have to look down my tree and I'd say, well, 2 and 2 add to 4. 3 and 1 add to 4. So there's only 2 out of the 6 that add to 4. So 2 pairs of numbers out of 6. How many pairs of numbers have a product of 4? So multiply to make 4. 2 times 2 and 4 times 1. Those both have a product of 4. That is also 2 outcomes out of 6. Number 4. I'd like you to try this on your own. Instead of doing a tree diagrams, they want you to look at the tree diagrams we did before and just fill in the chart. So number of branches at the first level, number of branches at the second level, number of paths total. Okay, so when we take a look at number 2, that of course is going back to question 2. Actually, while I've got question 3 here, I'm just going to fill this one in. There were 3 branches at the first level of this one. There are 2 branches at each of the second level, and the total is 6 branches. Okay, now I'm going to go back up to the previous one here. That's this one here. There was 2 branches and then 2 branches. Okay, so let me go back to blue just to separate. There's 2 branches at the first level, morning and afternoon, and either dance or writing for the other one, and a total of 4 different outcomes. Part B says, how can you calculate the total number of paths using the number of branches at each level? And we're supposed to take a look at this chart here and say, is there a pattern in these numbers? If I take a look at this number here in the example, there's 2 and 3. And the product here is 6. So if I multiply 2 times 3, I get 6. That's a total of 6 outcomes. Same with the second one. If I multiply 2 times 2, I'm going to get 4. If I multiply 3 times 2, I'll get 6. So when we want to find out the number of outcomes, we simply multiply the number of options for the first one by the options in the second event. Let's apply that then. Dean rolls 2 dice, a die with 20 faces and a die with 12 faces. He draws a tree diagram to see all the possible outcomes. Now this sounds like a nightmare drawing situation because you'd have to draw a tree that's got 20 branches, and each one of those 20 branches has 12 branches. I don't want to draw that. I can use what I've found in the chart here, though, to figure out how many different paths he can have, how many different combinations, simply by saying the number of branches at the first level would be 20. You could roll anything between 1 and 20. And at the second level, he could have anything between 1 and 12. Two separate events. He rolls one die with 20 and one die with 12. The total number of outcomes then is the product of the number of outcomes of the first and the number of outcomes of the second. The total number of outcomes now, okay? So we can see then that it's 20 times 12. I can do this with mental math. I'm just going to visualize that 20 is actually 2 times 10. It's easier for me to do 10 times 12, which is 120. So 20 would be 240. So there are 240 different branches in that tree. Definitely not something I want to draw out. That's something that would be much better to use this method here of multiplying the number of outcomes of the branches to find the total number of paths, total number of outcomes. And that is the entire lesson. That is it. So again, this is in your Jump Math workbook. It's on page 201. So I'd like you to kind of go through this on your own, make sure that you understand it. And that's this lesson here. I'm just going to